Okay, so number 16 on the review. What we have here, it looks like with these markings, we have a set of parallel sides. Um, so what I like to do with these complex problems is break them apart. I'm going to focus just on, if you look here, this transversal. There's a couple of transversals that we could be looking at. That's a potential. Okay, this one, and that one. All potentially could be transversals cutting through these parallel lines. So let's focus on this one first, though. What we have, that theirs is a little bit steeper, right? So what we have is something like this, right? What I want to focus on is the 30 here and the 6x there. Okay, what I try to tell my students is look for the z or the n, and what I mean by that is when the top and bottom of this are parallel, the inside corners, these right here, are your alternate interior angles. And oftentimes we end up using those. Now, these are alternate interior angles if you really look at it carefully. Okay, they're on the opposite sides of the transversal, other intersection, right? And they're between the parallel lines. So these two are alternate interior angles. And alternate interior angles are congruent when the lines are parallel. So all we got to do is set them equal, right? So they're always congruent. We're going to set them equal, divide by 6, and you get x is 5. So it wants the value of x and y. Got x. Now we got to consider how do we get y. All right. Now, one of the ways we can look at it is this transversal here. Okay, let's consider this one, right? If that's a right angle, we do know we could figure that one out. Those are going to be consecutive interior angles, and those are supplementary, or add to 180, right? Well, this is a 90-degree angle. The right angle symbol is 90 degrees. So if we called this, I don't know, another letter, z, right? You'd have z plus 90 equals 180. So that entire angle is 90. All right, from now on, you know that, right? These are all going to be 90s. If you've got parallel lines cut by a transversal and there's 190, then they're all 90s. All right, so going back to this, we already have a 30. Okay, so this is tricky here. Let me just put that together. So focus on this part right here. Try to break it down for yourself. Okay, you've got this here, right there, right? That's 90. We just established that right here. So what we have is this 30-degree angle right there, right? But the whole thing is 90. So we could say 30 plus whatever this is, 7y minus 3 equals 90. So that's what we'll do. So solving that, let's combine like terms maybe, the 30 and the negative 3, 27, or I'm sorry, plus 27, this is positive. Okay, so then subtract 27, and you get 7y equals 63, divide by 7, and y is going to equal 9. So we get x is 5, y is 9, all set on that one. All right, the next topics are the construct a segment. I'm going to go over to Geometry Sketchpad for these, so bear with me. Okay, so we're trying to do number 17, construct a segment. What I'll do first is show you on Geometry Sketchpad kind of the purpose of this, okay? So we'll talk through some of the concepts. When you construct a segment, we've got to back up. We've got to understand what's going on here with this compass tool, right? We're going to put the center of the compass tool on A, and we're going to go out, put our pen in a radius so that we draw a circle that goes right through B. Okay, try to imagine that that's what's going to happen. I'll go and I'll do that on the other video camera after this, but I just want to establish what is going on. We put our center of our compass tool there, right? And we put our pen or pencil in the radius that goes through B. What you end up creating is a circle. Okay, really simple. Now, if they don't tell me to, here's what I would use. The concept I would use is all points on this circle are the same distance from A, or radius of the same circle are all congruent. I would just put a dot anywhere, okay, a point anywhere, and I would leave A where it is. If I connect now with my straight edge, this segment is guaranteed to be congruent to that segment because it's the radius of the same circle. Now, they're probably not going to let us get away with that. They're probably going to put a point C somewhere else, okay? So let's try that, all right? So what's going to really happen is we're probably going to establish another point right there, okay? Let me get rid of that second one. So let's call this C. All right, I'm going to copy that segment. Here's what I'm going to do. Same thing. I'm going to put my compass tool here. I'm going to open it up. I'm going to figure out which spot it is that's going to pass through B. I'm still going to do that, construct that circle. Now, typically we don't construct the entire circle when we do this. We only need an arc that's part of the way, okay? So really that's all we need is to go from here to here, okay? I'll show you that in a minute. Okay, so really we don't need this whole circle. Here's what we'll do instead. We'll just kind of hide some of this. Really all you need to do is go about this far, okay? You don't have to show the whole thing. Basically what you're doing is show enough to know that you use your compass tool, you didn't just freehand it, and we can tell that you are keeping track of what radius you used. Now what you're simply going to do is you're going to go back and you're going to use the same exact radius, but put your center point on C. Same idea, you're going to construct a circle that same exact size, and all you got to do is pick any point on that circle, okay? So we'll call that D. And once you connect them with a straight edge, there it is. Okay, and again, you only need about that much of the arc. You don't have to do the whole thing. Okay, so let's construct a copy a segment. Okay, next one's copy an angle. Okay, construct the same angle. Now that's going to be much more tricky. So I want to go over again to Geometry Sketchpad, and I'll show you that. Okay. So we'll get rid of that other previous diagram, get rid of this. And this can be any angle. Let's just put this as a ray. Okay, and then I'll just create another point up here to get our other ray. Okay, so we've got our original ray. And what we got to do is realize that these points that they may give us, are not necessarily the same distance from A, right? Because C could be further or closer, B could be further or closer. What we got to do first is we've got to find a way to measure this angle, but using a compass tool. It's a little odd. What we're actually going to do is we're going to put our center point on A, and we're actually going to pick any radius we want. I like to go out a little bit. I don't actually hit either one of the points, but I do like to make my circle reasonably sized here. Okay. Now, I'm going to copy the angle from here. All right, I'm going to copy it down to here, and I'll call it angle D. Okay, so I'll give myself a little bit more room. I'm going to copy it down there. Let's see. So you're really copying, let me just catch up here. So you're really copying just the opening between the two sides, how much the opening is between these two sides. So I can really establish any other ray I want. We'll call it DE. And really, I don't have to measure that. So this is basically a copy of this ray. Right? Now to copy an angle, I have to get the same opening from this side to that side. All right, so I'm searching for F. I got to put F in a distance that's going to make it the same angle measure. So watch what we do. Very first thing, I am going to use this radius to make my first circle. It's a little strange. All right, here's what I've just done. By making a circle centered at A that passes through both sides of the angle, okay, this is crazy, but this is what I'm really doing. I'm actually creating a segment. Nobody ever does this, but you're really creating a segment to copy. You're actually going to copy that segment because that's the size of the angle, believe it or not. Okay, so this is really, that segment here is really the size of the angle. But you got to understand this far away from the vertex. What do I mean by that? Okay. So I picked a radius for this circle centered at A. So if you use this same sized circle and you want to get the same angle, it's got to have the same distance between its two sides that far away. Okay, so here's what I'm going to do. I'm going to use that same radius on D. Okay, construct the same circle. See that? I'll slide it down more so it's not in the way. They'll not, these don't have to cross. So what I'm saying to you is, you see this point right here? I'm going to copy that segment. I'm going to do the same thing I did in the other problem. You're really copying this segment, which represents the size of the angle this far away from the vertex. Well, I've already got the distance away from the vertex established, right? I used the same radius here as it is here. Here's that point. It's copied right there. Okay. Now all I got to do is copy this length. Okay. You're going to do it the exact same way as we copied a segment. So center of your compass tool here. Use this radius from here to here and construct the circle by center and radius. Now, what do I do here? Let's see. If we go further away, does that? All right. That's just luck that it happens to go through here. You know what? I'll make this closer together. That won't usually happen. See that? So that's better. So this circle doesn't always go through D. It did last time, but I didn't want you to see that. Okay? What I'm saying here right now is this distance from here to here is the same as that distance. So the opening between the two sides is the exact same. So that's what copying an angle is all about. Get the opening between the angles the exact same. Okay, that's copying your angle. I'll stop this one and we'll go to the other constructions after.